Are we going to do this? Right, so have you guys done big O this stuff already? You did it in 1019 with me if you were there, right? Right, so we want to, the advantage of doing this is to make our lives easier, right? Do I care about all these little details? No, I don't, right? We drop the low order terms, we drop the 3 in front, and we just get order in square cubed, right? People remember that? And if we're really going to be, I guess I didn't think we were going to do it, but now I guess we're doing it, right? What are we saying here? F, we want to talk about F. And I'm going to say that F is kind of bounded by G. What does that mean? Well, if you get G times a really small number, this is G times a small number, and this is G times a big number, and it's squeezed between them, right? But for which C? I'm trying to prove they're squeezed, so I get to choose the C's, right? I can make my C really, really small, my other C really, really big. The only requirement, I didn't write it down here, the C's got to be bigger than 0, right? Everybody good with that? That's the game we've been playing already. And then, for which n? For all sufficiently big n. For what definition of sufficiently big? I get to choose it, right? So let's do some examples, right? Here is 8 n, is this function here big O of n squared? Yeah, right? Because you drop the low order term, which is 1,000, you drop the 8, and you get n squared. All right, so let's play the game. I get to come up with the C and the n naught, right? And I'm going to make the n naught 1,000 to get past this stuff. And I'm going to make it 9 because I really want it to be 8, but it's got to be bigger than to eat that stuff. Right? People see that? And then he comes up with an arbitrary real number, an arbitrary number, but it has to be bigger than my n naught. It has to be bigger than my 1,000. And I say a real number here, but usually we're over the integers. I don't know why I put real in there. And then we have to check to see that this is true, right? And you crank it out and it's true. Everybody good with that? There's a single C, and that works for, right? 9 works. When n gets sufficiently big, 9 will always, 9 n squared is going to always dominate this for sufficiently big n. All right, so is this one true? N squared, is it big O of n? Come on, guys. No, it's not hard, all right? So I come up with a C, some really, really big C, and I come up with some really, really big n naught, right? And then the adversary comes up with an n. And what n is he going to come up with? It's going to be bigger than my C. It's going to be bigger than my n naught. And just to make life for sure, it's going to be bigger than 3, right? And we plug it in, and it's true, right? Why did I make it bigger than 3? So that 2 to the n was bigger than n squared, right? That's why it's bigger than 3. What, then this, well, his n's bigger than my C here, right? Everybody good with that? What about this statement? Is it true? You all should be experts by now. This is the kind of thing we're going to make you do, right? Let me remind you what's going to be on the test. I am going to make you prove The hard things like merging, not merging, what was it called? Converging, right? Using the oracle and the prover, right? But in the future, I will tell you whether it's true or not, right? But I'm also going to give questions like this. This is perfect questions. Which of these are true, right? And maybe I'll ask you, give me a few sentences why it's true or false, right? Is this one true or false? Right? It's true, right? For all n, how do you do it? The adversary gives me an arbitrary n, right? Here's a specific one, but something big, right? I come up with the c. Well, I know is n. So I make my c to be exponentially bigger, right? And then look at my c is bigger than his, right? Everybody follow that? All right. So we're not covering this, but theta means you're bounded on both sides. Big O means you're bounded above. Omega means you're bounded below. Little o, big O. I don't know. We're not doing all of these. Everybody good? Let's do one more example here. How are we doing for time? 20 minutes. All right. Right. So let's do another one. Is this true? Is this a polynomial? Right? So the way I read this, if you haven't taken this stuff from me, theta of 1, I consider to be, well, it's bounded on both sides, but let's not worry about that. It's a constant, right? It could go up and down. It could be a wiggly constant, but it's bounded. And this says n to some wiggly constant, right? That means a polynomial. And is this a polynomial? Yeah, it's a polynomial. Even your high school teacher would say it's a polynomial, right? So how do we do it? I guess we're not doing it. We're just talking about it. All right? What about this? 3 to the n equals 2 to the log 3 times n. And when this n here, it's just not an issue, right? So this is all 2 to the some constant times n. Everybody good with that? Right? Any questions about this one? All right, how are you guys doing? Have I killed you? Does it feel okay? Right? I promise you're going to need to know those things when you're talking even to system engineers. They're going to say the word polytime, and you have to know what it means, right? Any questions about anything? All right, so now we're going to talk more. Yeah? Good, because I throw these things up here, nobody complains. Simon complains. What? Why don't you complain? If Simon didn't get it, you didn't get it, why didn't you complain? All right? What's the definition of log 3 base 2? What's the definition? It's the number that when you raise it to the power of 2, you get what? You get 3, right? That's the definition of log, right? What's the log of 8 base 2? It's 3. Why? Because 2 to the 3 is 8. 2, 4, 8. I got it right. There was a chance I got it wrong, but I got it right. Everybody good? Now, I'm trying to understand 3 to the n. Well, 3 to the n is 2 to the log 3, right? That's 3, right? To the n. Now, I got this to the this. What do I do with them? I multiply them. 2 to the log 3n, right? And this is just 2 to the c times some constant, right? Oh, yeah. So I haven't done the n yet, all right? I'm just doing the 3 to the n is 2 to the log 3 times n, right? And what is log 3? It's 1 point, I don't know, it's a little bigger than 1, right? So I'm bumping my c up a little bit here from 1, right? Now we also have an n here. What do we do with n? Well, n is 2 to the log n. Right? Everybody got 2 to the log n? What's 2 to the log n? Yeah, base 2, right? Is n, right? So here we got right 2 to the log n, and so now what is here? We're multiplying this. So what do you get here? Did you get an addition plus log n? No, not for me. I write my statements down with the theta so that it eats what the log is, right? It doesn't matter. If I changed this to a log, some other weird log, it's just going to change my c, right? The whole point of doing these things is to not care about details that you don't care about. And a detail I don't care about is the base of a log, right? If you like, make it base 10. If you might like it base, right? Very good, right? Are people following this? And the point is all of this here, and here's another way of doing it. Would you say that all of that is bounded by 2 to the 10 n for big N? Right? Look at what we got there, right? We've got 3n times n, right? For big N, this is bigger, right? So it's bounded by 2 to the cn, right? I can put in here into the billion, right? It's still bounded by this for big N. Right? Everybody good? What can we slide under the rug?